Okay, synthetic division is way easier than long division. The first thing you want to check is to make sure your terms are in decreasing order by degree. So you want to make sure that your exponents decrease. This is an x cubed, this is an x squared, this is an x, and you have no x's. So those are in decreasing order. So the next thing you want to do is you want to write a list of all the coefficients. This is the leading coefficient is 5. The next coefficient is 7. The next coefficient is a -1. And this last coefficient is -3. Okay, you make a list of all the leading coefficients. Then I usually make a box out to the front here. And you take the constant term of the divisor and you flip the sign. So this is a positive one, so I'm going to flip the sign to a -1. The next thing you're going to do is you're going to bring the 5 down. And then you're going to do this pattern throughout. You do whatever's in the box times the very bottom number, so -1 times 5 is -5. Once you write that up here, then you're going to combine 7 and -5. So 7 plus a -5, or 7 minus 5 is 2. Then you start again. You do -1 times 2 is -2, and then you combine these. A -1 minus 2 is -3. You do -1 times a -3 is a +3, and -3 plus 3 is 0. So you're left with these. These represent the coefficients of your answer. The last term represents the remainder. Okay, and since these are coefficients, these are what are going to go in front of your x values. The first term you start with is 1 degree less than what you started with here. So since I started with x cubed, my answer is going to start with x squared, and that 5 is the leading coefficient of that x squared. Then since this is a +2, I'm going to have plus 2x, and then I'm going to have this -3 as my constant term. I have no remainders, so I have none left over here. Okay, let's try another one. Let's look at this one. Here we have x cubed, we have -8x squared, we have plus 19x, and -9. So our degrees are in decreasing order. We have this is being multiplied by each other, but we have this to the negative first power. What the negative first power means is to divide by whatever that negative first power is being applied to. So this really means we're going to divide this whole thing by x minus 4. So again, we're just going to use synthetic division. So I'm going to start with my leading coefficients. Since all the degrees are in decreasing order, I have a 3, 2, 1, and a 0. I'm okay. I'm going to write a 1, a -8, a 19, and a -9. Then in my box out in front, I'm going to do the opposite of what this is. So since that's a -4, I'm putting a +4 here. I'm going to bring down my 1. 4 times 1 is 4, so I'm going to write 4 here. I'm going to combine these. If I'm going too fast, pause the video. -8 plus 4 is a -4. Then we multiply -4 times 4. -4 times 4 is a -16. 19 minus 16 is 3. 4 times 3 is 12. A -9 and a +12 is a 3. That last number always tells you your remainder. Okay, the next thing you need to do is, what is your first term going to be? Since this is an x cubed, you do 1 degree less. So our first term is going to be x squared. So we have 1x squared, and we're going to have -4x. Then we're going to have plus 3. When you have a remainder, just like we did in long division, you take what you're dividing by, that x minus 4, this x minus 4, and that becomes the denominator of your fraction. And that remainder means you have 3 remaining that still need to be divided by that x minus 4. So the way you write that, since that's a +3, we're going to add the remainder, plus 3 divided by x minus 4. Okay, let's try this one. Again, you want to check your degrees. You want to make sure they're all there. If they're missing, we're going to do an extra step. Here we have something to the 4th, the 3rd, the 2nd, the 1st, and 0. Again, you have a negative exponent here. That just means divide by this binomial. So we're going to do synthetic division. Okay, you're going to write out your leading coefficients. 1, -4, 1. Remember, any variable that doesn't have a coefficient in front, it's an invisible one. Here we have 7 and -2. Okay. You're going to take the constant in the binomial, put it out in front here. That's a +2. We're going to bring down the 1. 2 times 1 is 2, so we're going to put it up here. Then combine those. A negative 4 and a positive 2 is a negative 2. 2 times negative 2 is a negative 4. 1 minus 4 is negative 3. 2 times negative 3 is negative 6. 7 minus 6 is 1. 2 times 1 is 2. And negative 2 plus 2 is 0. That last number always tells you remainder, so here we don't have any remainders. Since I started with the x to the 4th here, my first term is going to be an x cubed. And this is my coefficient, so I have 1x cubed. Then I'm going to have minus 2x squared, minus 3x's, and plus 1. Okay. This last one, when you check your degrees, I have x to the 4th, x to the 3rd. I'm missing an x squared. I have an x to the 1st, and I have a constant. So the next thing you want to do, if you're missing a degree, you want to fill in, you want to add plus 0x squares. Okay, so if I were to write this out again, I would get x to the 4th minus 3x cubed plus 0x squares plus 5x's minus 6. The reason why you do that, this will serve as a placeholder when you do synthetic division. If you don't do that, you will get the wrong answer. So we're going to write out our coefficients. The leading coefficient here is 1, then negative 3, then 0, then 5, then negative 6. Okay, then we're going to place this the opposite of the constant here. So that's going to be a negative 2. And then we can start with the 1 here. Negative 2 times 1 is negative 2. Negative 3 minus 2 is negative 5. Negative 2 times a negative 5 is a positive 10. 0 plus 10 is 10. Negative 2 times 10 is negative 20. 5 minus 20 is negative 15. Negative 2 times negative 15 is a positive 30. Negative 6 plus 30 is 24. Again, that last number is your remainder, so we're going to have a funny fraction in our answer. The first term we're going to start with, since this was an x to the 4th, we're going to start with the x cubed. So I have 1x cubed minus 5x squared plus 10x minus 15. Then we're going to add the remainder, which is 24, that still need to be divided by whatever we divided by originally, x plus 2. Normally you write that all in one line, but I ran out of room. On the back, we have 2 word problems. This first one, the area of a rectangle is represented by this polynomial. The width is x plus 4. We're trying to find the length. If you do area of a rectangle, if you know that that's the length times the width, okay? If I plug in my length here, and I'm trying to figure out something times the length to give me this area, okay, that might be a little tricky. So let's solve for the length, okay? We already know what the width is. We want to know the length, so we want to get L by itself. If I want to get L by itself, I'm going to divide both sides by W. W divided by W is 1, so it leaves me with 1L. And so I know the the length is going to equal the area divided by the width. Okay, well, this is my area, so I'm taking my area and I'm dividing it by the width. Okay, so we got that divided by that. We have a polynomial divided by a binomial. We can do synthetic division. You got x cubed and x squared and x and a constant. So the first thing you're going to do is write out your coefficients. So this is 1. The next one is 8. We have 13 and negative 12. The leading number in front is going to be a negative 4 because you got to flip the sign. Bring the 1 down. Negative 4 times 1 is negative 4. 8 minus 4 is 4. Negative 4 times 4 is negative 16. 13 minus 16 is negative 3. Negative 4 times negative 3 is a positive 12. Negative 12 plus 12 is 0. So you have 0 remainders. And then the first term, since this started with the x cubed, we're going to start with x squared. So we have x squared plus 4x minus 3. And that is the polynomial that represents your length of the rectangle. If you multiplied the length times the width, if you multiplied those, if you FOILed that one out, you would get this polynomial expression here. The last one, the U.S. Department of Transportation limits the time a truck driver can work each day to 11 hours. For the first part of his trip, Tom drives at a speed of 60 miles per hour. For the second part of the trip, he drives at a speed of 70 miles per hour. Write a polynomial to represent the distance driven. Okay, so let's, we're going to let x represent the number of miles he's driving at 60 miles per hour. Okay, I should have told you that in the word problem. So the first thing we're going to do, we're looking for total distance. Okay, so this first part is going to represent the distance at 60 miles per hour. This is going to represent the distance at 70 miles per hour. Okay. To find the distance, you have to figure out the speed times how long he drives. If he drives at 60 miles per hour for just an hour, he's going to get 60 miles. So I'm going to multiply 60 times the, my bad, this is going to be the time he spent driving at 60. The number of hours he spent at 60. So we're going to do 60 times x. If he drives for 2 hours, the total distance is going to be 140. If he drives for 3 hours, the total distance is going to be 180. So that's going to represent the time he spends driving 60. Since he can only work 11 hours a day, if he drives X hours the first chunk, we got to figure out how much he drives the second chunk. Okay, he's driving at 70 miles per hour. We got to multiply 70 times something. And we have to figure out what's left over. If he drives X miles already, we have to take X away from 11, and that'll give us how many miles he has left over. If he drives 2 miles here, 11 minus 2, he'll have 9 hours left to drive. If he drives 3 hours here, 11 minus 3, he'll have 8 hours left to drive. But since we don't know, we have to do 11 minus X there. Then you're going to simplify this equation, or this expression, so we're going to distribute that 70. So we have 60x plus 70 times 11 is 770, and then 70 times a negative x is a negative 70x. Okay, then we combine like terms, 60x minus 70x is negative 10x, and then we have that 770 there. So there's your polynomial that represents the distance he drove.